And we're back. Okay, so I did some thinking over the weekend and shit. I haven't touched a single thing of code. Let me prove that to you. Most recent, June 4th. But I thought about how we're gonna store snapshots, which is basically how we're gonna keep track of the order book. And one option is to just malloc and free everything, but that seems slow because there's a lot of system calls. So instead, I thought about it, and we're going to need basically two structures. One is going to be a circular buffer of metadata, and the other one's actually going to hold all the like stuff we need to store. So, but first off, I do want to add a few things that I kind of have the same priority. But I need to make this explicit. If you ever swap it, we need to change this. Okay, that makes me happy. The other thing is in the FL is free list. Free list, I thought about this, and I know we said order here. Order is, oh, it's only used 3 times. I'm just gonna be a little bit lazy, and we're gonna do, who has it open? Oh, instead of defining this, we're gonna define, I don't know, uint 64. What are we putting into this free list? Free list. Capacity, I'm gonna hard code for now. It's gonna break once we hit 124, but that's okay. I need a smaller version working. I guess this is fine to have, but it's just not gonna be passed in. It's gonna be explicit, and it might double. I eventually want it to double. Okay, but we're also gonna do, it's not gonna be capacity, it's actually gonna be size. And we're not gonna need order anymore, we're gonna do void star. And that's it. Cool. Order is just happens to be defined here, we'll move here. It was never gonna be here, anyways. Let me just make sure I got this right. Hold on, we can close this and this guy. Void star. What can we do with this? Void star. One match. Okay. What the fuck is this? What is a void star? No AI answer, just here we go. Is it like a wildcard? Any data type that may store the address of any data type. Okay, well, unfortunately, okay, so, Okay, this is interesting because we can work with this, but basically insert is not actually going to take data and put it in. It's going to take a request, it's going to return the index of that request, and then the caller has to go ahead into the index and assign whatever they need to do, which is actually, all right, screw this. I'll do this later. The only reason I brought it up is because we might need free lists elsewhere. Okay, whatever. What's going on here? Okay, get checkout dash dot. Okay, let's work on the next thing that we have, which is going to be updating the make file so that we can just add whatever we want ever. This is not going to scale. What we're going to do now is, yeah, let's get the make file working first. Let me see. So, how do we do this? Okay, let me make file documentation. Here we go. You know it's from GNU, so it's real. Get out of here, bug. What about the rules? What and variables? Here we go. Yes. Okay. Okay. In our example. Okay, I'm just gonna like fly through this real quick. Okay, here we go. Yes, we have commando, we have displayo, we have inserto, searcho. We need to make all of these, and this is very similar to what we're doing, except we're not using the .o output. Wait, is this CC or GCC? Oh shit. It also needs various header functions, huh? Okay. Yes. Yes, we have KBD and we have KBD, which is ridiculous. It is standard practice for every makefile to have a variable named objects. Okay, let's not be weird then. Let's do objects. So we'll do objects is equal to main. I'm so confused. What's going on here? Why does edit need main? All right, whatever. Just confusing me. Rand PQ FL. Yes. Okay. That doesn't look that simple though. This really does not look that simple at all. They're also going to be in out. They're not going to be in that directory. Okay, hold on. Should we rename them to .o then? No. Okay, let's check the Linux one. Surely. Okay, let me find the last example and just parse through it. Or maybe rules? I think we need rules. Recipe. Uh-huh. Here we go. That's exactly what I was looking for. Yes. What does this look like? Okay, I think this one's like good enough for now. I'm sure there's like a better perfect example, but whatever. Where'd it go? 5 matches, hold on. Oh, this is only the first one. No. Oh, it's the only one that matters. Okay, cool. Oh, we could add suffix. Actually, I'm not gonna mess with this. I have no idea how it works. Okay. Rand O. PQ.O. FL.O. Cool, so that's objects. So now we can just do OBJDIR, which, so I think this means for every, oh, is this like a rule? What does this even do? Oh, wait. Huh? So confused. Oh, okay. Let me just copy it and mutate it to be what I need it to be. To make each one, we need... But then how do the header files come in? Okay. We need to make a... first of all, the C file needs to be there, which I think it's there. I don't know. Oh my god. Okay. And then once that's required, we do compile.c output option. What the fuck is this? Okay. Oh, right, we need to use tabs. Or, yes, we do need to use tabs. Hold on. Let's get a tab real quick. Okay. Wait, I'm not confident in that. Paste. A. We can just do GCC C I include. How do we output op? I'm so confused. Wait, what? What is the output option? It's not defined anywhere. this. Hold on. The only thing that this helps us with is the following. We can now do OBJs, which might be enough for what I need. And we can do the same thing here. OBJs, and there we go. And the other thing we can do is we need to somehow figure this. How do we do this? How do we fucking do this? Compile out does not rely on that. It relies on. Oh, yeah, this is a really good one. I'll keep this one. Get you a tab real quick. There. Yeah. And then we don't even have to have that object directory at all. Objects require object directories, that makes sense. Let's just see what happens. Right. How silly of me. Where's that tab? Oh, right. Let's just see what this does. Maybe this is all we need. No rule to make target compile out. Right, it relies on a compile out, but we actually want to rely on the objects. OBJS. Same for this guy. So once all the objects are compiled, we're good. Cool. Of course there isn't. Now how do we make it? Okay, what is this? What is this? If I can figure this out, maybe I can, wait, maybe we just throw in output option and see what happens. Output option. I swear to God, if I just spend like hours on just figuring this out, I'm gonna be mad. Let's see if this even does anything, by the way. Okay, make their out. Okay, why is it not? Why is it skipping that rule? I don't like this. OBJs requires, wait. Oh. Oops. Wait. Oh, my bad, bro. My bad. Wait, I feel like it doesn't actually matter. Maybe it does. Let's find out. Talk to me. No. Oh. Most important one. No. Okay. What? Maybe we need to do all. And all is OBJS, and OBJS is, what is this? Does this mean that we add this to all requirements of this, but then if we only have this, then it kind of overwrites it. So maybe, oh shit, we already do have it. Damn. Okay, maybe we need to rely on all, not just OBJS. Talk to me. No. Okay, I don't want to... This is a little annoying. Okay, what the hell is this? What is this? Oh, to the first prerequisite in the first rule for this target. Ooh. So this is that C. It's that C. Wait a minute. Yeah. So this is not needed anymore, I think. So this is that C thing, but we also need to do out. Wait, what else do you need here? You have GCC, you have OBJ dir. Like, what else do you need? Slash wait. Variable. Variables make it simpler. I'm just gonna scroll through and see if I can find what I need. Oh, here we go. So, what is this? What is how does this become something in here? Is it this thing? Is it what is oops. What is this? What do they do? Oh, name of the target. Okay, cool. Name of the target. Okay, so we can just do name of the target then. So that this looks so weird, but who knows? All right, let's see it. All right, cool. What if I specifically do make pq.o? Cool. Make out pq.o. Nice. Wait, what do you mean nothing to be done? ls out? ls? ls source? What the fuck? Nothing to be done for pq.out. Really? Really? Because it looks like you need to do this, no? It's right there. Make out pq.o. Why is this not working? This is what real software engineering looks like. Do I have this in the right order? Wait, what if you can run anything here, right? My bad. I forgot. Does that even work? Okay. It's right there. What are you talking about? Maybe it's this. Nope. Wait, it's right there. Wait, what? Wait. What? Maybe. Oh, wait. Why is it like this though? Like, do we need OBG there and the other one? Why? Can we just use? Oh, because we need to get the Okay, no rule to make target out there. Okay. First of all, it's right there, so you're wrong. Second of all, did I just do it wrong or? Maybe make out PQ? Uh-huh. No rule, wait, what? Wait, okay. That kind of helps, I think. No rule to make target PQ.O needed by PQ. Okay, where is PQ coming from? Is it from all? No way, that doesn't make sense. Wait, how is, oh, is this like a catch-all? Okay, I see, so that doesn't help. What about, okay, it's right there though, like I don't, like it's right here, that's the rule. How are you not finding it? What if we did make out? RMRF out, make out. Well, oh, because this, right? Make out. Okay, cool, it's made. Now, if we do make out slash PQ dot O, did I not copy this correctly? OBJ there. O. This is a wild card, right? No. How does that even work? Okay, what is this? What is this? Okay, I feel like this one's just wrong then. Okay, this is a lot closer to what I'm doing. Why is this still not working? I don't get it. Why is that so hard? Okay, maybe I'm making this too complicated. What if we just did for any out file, we need this file, and we can just do obj s is equal to ran.o pq.o fl.o. Okay, and then for any of these guys, right? We just need to do output directory is going to be obj there. Okay, that's it. So we're just going to compile, and then don't worry about this. And then we do it's not going to be objs, it's going to be, maybe call it like final objs, out objs, I don't know. And then we rely on this is a rule, not a, wait, I'm so confused. Wait, but how's it finding the C file then? I don't get it. This relies on out objs. Same thing here. Oops. Out objs. Let's try this. It's right fucking there. Oh, sorry. There. It's right there. Like literally right there. What are you talking about? I want to make a pq.o. Why can't I make a pq.o? It's right. It literally says it right there. Like, what is going on? Something over. Okay, let me just get rid of everything else. There. What the fuck is? How is there no rule? Okay, whatever. Okay, out slash. Here's your fucking rule. It's right fucking there. What are you talking about? What do you mean? It's right there. The rule is right there. What are you talking about? I don't get it. It's right there. No. Out? Oh, like I don't get it. Okay, fine. How about this? How about I make it explicit? Rand.o. Okay? All you need to do, GCC C I include this shit. There. Is that obvious enough? Okay, here we go. Now you found it. Congrats. Okay, so you can call it, huh? So you can call it. All right, bet. What about this? Okay. All right, I think we're starting to get somewhere. Oh wait, no. No, we didn't do anything. Oh wait. Why did it run twice? That makes no sense. So you need a rule, but you can't have two rules. Is that right? All right, let's get rid of this one then. Oh, need the. Okay, there. It's oh, Oh, PQ. Now we're bitching about PQ. Okay. Okay, how about this? There, you have all of them. Okay. This seems closer to what we need, unfortunately. Okay, I think we can replace... That's different. That's different. Okay. Okay. I think they all just got compiled to... Okay, let me just try this. Let's see, okay? This. How about that? Not quite. Not quite my tempo. Again, it's right fucking there. I don't know what you're on about. Alright, fine, here. Took my balls. Right. Well, that's great because it's right fucking there. Maybe something like that. Is that all we need? No. Okay, why is this messing it up so much? I don't get it. Let's see. Make file not supporting pre. Wait, maybe it's this actually. Hold on. Maybe it requires the presence of this guy. Oh, okay, that's different. Unable to open output file. No such. Well, it looks like I at least tried something. So I'll play ball actually. Let's make it through out and then. Oh. Okay, cool. So we just needed the source because our objects, our shit wasn't set up perfectly. Okay, so this is the golden rule. Don't break it. And I think now we can really mess around with this. Let's get rid of everything that wasn't really necessary. Maybe this guy. We can bring this guy back. Maybe it's probably gonna break it anyways, but whatever. Actually, I don't think we need OBJS anymore. We can just directly use out OBJS. And I think that looks good. Let's try this. Make clean. Make test. Nice. Let's get rid of this shit. Wait a minute. I did make clean and it called these three. Why? Something tells me comments aren't really doing what they need to do. Anyways, all we need to do is clean up a little bit more. This one's commented out anyways. Okay, cool. In fact, we could probably get rid of the .o. We don't even need it anymore, I believe. Or is it convention? No. Or clean, make test, make main. That's just random number generator. Don't worry too much about it. And actually, yeah, you know what? I kind of like this. Okay, cool. Let's add a new one. We're gonna call it bs.o. Actually, before we do that, I'm getting ahead of myself. Git status, make sure nothing is, okay, cool. Okay, cool. Git commit, much more flexible make file. I know there's no options, but whatever. Now we're gonna add bs.o, and that's all we need to do. We just need to add it there, and it's all good. Now we can throw in a few more things. We're gonna do, I'm gonna show you how we're gonna use it actually. So let's go ahead into tests, and we're gonna do, wait. How the Oh, because they're in the same directory, they get compiled. Okay, cool. Let's do main.c, and we'll just throw in BS, and we'll test BS. What does that look like? I'll show you. We're going to copy tests. Let's go into tests. CD to test. Copy, let's say test, probably going to be close to the free list, to test bs.h, via test bs.h, and we're just going to do a few quick things. We're going to have bs, and text, let me just get the printout testing blob store, by the way. So that's what it's going to call. It's what it's going to be called, and we'll get back to that in a second. BS, oh, here we go. RBS, and then here we go. Cool. So what is this going to look like? What are we actually going to do with this? I'm going to try to build it in such a way that this blob store does not need to know anything about what it's actually inserting. So with 2 hours to go, what do I need to do? Here's what we do. BS is equal to BS init, and of course BS free. Can't forget those. Very important. Okay. In between is what we make a new. Wait. See, this is the exact error. This is the exact issue I ran into with the free list earlier. Okay, what I just gestured with my fingers is we're basically going to emulate malloc, but without using malloc, or we're only going to use malloc once. And you'll actually see how this could be kind of interchangeable with malloc. I'm actually not totally convinced of my solution. I might have to, I might swap it with malloc and free if it's better. But basically, we're going to get an address in which it's safe to write through some range, and then the caller that gets the address is going to write into the range, not the system I'm about to write. So we're going to do something like BS get or like, I don't know, reserve. Yeah, because it's really reserving. We're not actually doing anything. We're going to need the BS itself. We're going to need, what do we need? The metadata, I'll tell you what the metadata is going to store. It's going to store the size of the block, the offset into memory, and the ref count. So we probably want to pass in size and ref count. Refs because when we, not to spoil it, but we're gonna have a snapshot. We're gonna have a snapshot of the order book and a few clients, simulated clients that have that are listening to every one of these snapshots. When they get the snapshot and read it, it's kind of like they're not gonna need that information again. They'll take the snapshot, they'll update whatever state they have for trading, and then we can kind of scrap that snapshot. But we can only do that after all the clients that will get the snapshot are going to do that, are done with it. Plus the server. The server is also going to take the last snapshot and use that to get the next snapshot. So there's like, it's kind of like refs plus one, but we'll get to that. We can just pass in refs for now. So after that, we use BS address. We actually don't even need to write anything for this test. We just BS address oh God, wait. We have this chunk of raw memory, which is the exact size we need. Oof. Okay, so basically when the server gets an order, we need to reserve a snapshot. Wait, what if we don't know how big what if we might need to do some copying, but that doesn't sound efficient. Okay, whatever. Well, for now, we'll just say, I don't know, 0 is equal to 42 or something. We'll just pretend, we'll write into that, okay? We also need to do, oh, fuck, actually, there's another thing we need. The other very important thing that we need is a handle on this BS address. And we could just use, oh no, we can't. This is a 64-bit, this is a 64-bit address. We cannot use that. What we actually need is something more, wait, is this gonna be a 64-bit address? What the fuck is this gonna be? This can be a 64-bit address, but there has to be something else that's like maybe 16 or 32 bits that, okay, we need to return multiple things. Here's what we're gonna do. We're gonna do void star BS address is equal to 0, and then we're gonna pass this in. We need to, yeah, this smells like a fucking security, vulnerability, but fuck it. So, yeah, so I believe it's, can we just pass in BS address, or do we need to do like the address of BS address? All right, whatever. Anyways, something like this. Uint 30, let's say 32 for now. And this is going to be something like a snapshot count, but we'll call it BS. Actually, doesn't really matter. BS account number, BS number is equal to that. So this is going to return a handle into this, and this we could swap these two. Like, we basically need to return this address and the BS number, and this is how we do it. So one of these has to be kind of created before and passed in, and we just assign it. Oh wait, this is like an address of an address, right? Or wait, if we pass in an, oh, okay, this is an address. Oh, this needs to be like, okay, whatever. So we have the BS number. We set BS address 0 to 42, and then maybe like this is like basically the server creates snapshot, and then we then you take that BS number, you send it to the clients. The clients use the BS number to read it, and that is actually yeah, that's actually pretty important. BS get. And it's going to be, we're going to take a BS number, client reads it, BS number, that's all you need, or BS and BS number. And we can do, what is this going to return us exactly? Oh, fuck this. Okay, nice. Well, I guess it could just return, we have this metadata free list. It could just return, it could just return the metadata. So ref count, offset into memory, and size of block. Or whoever, no, before we call the client. So when we have an event scheduled, a scheduled event where the client gets a thing, someone will call this. and then someone will go into the thing and actually get it. But for now, the person who's like, this won't make it to the client interface code basically, but this will be something like BS metadata star, BS. What am I doing here? BS metadata. All right, we'll call it BSM. Yeah, that's not a thing. BSM is equal to that. Okay. Yeah. Okay. And we can do BSM ref counts. Which actually, now that I think about it, someone needs to call BS get, and then someone else needs to do that, and then offset, and then BS size. Offset actually doesn't make any sense unless you have the base, like the lowest value possible, which is only available from within the BS. And then the size is the size might actually not be necessary. If we can just get the wait a minute, we can do BS get. Okay, the thing about the snapshots is that they should have enough information to be like, okay, we have X amount of rows, like we have X amount of price, like information, okay? So as you go through each price, and then within each price, we're gonna have a certain amount of asks and bids. And we need to jot down how many asks and bids there are, because otherwise there's going to be no way to parse that file. Unless we do like a null terminator, which is going to take an extra byte anyways. Yeah, and also the shape of this data is just whatever, so we need to trust that the client knows what it's doing. Actually, if the client reads past the edge of that data, they will actually read into the future, because we're going to put the next snapshot right after that snapshot. So this is a bit of a security thing. Okay. Yeah, this is a... Yeah, they can't read past the snapshot, so... Maybe we need someone else to actually parse the data. Yeah, so I don't know, we'll get back to this. But anyways, we do that, and then eventually, if you call this enough times, the ref count goes to 0. Actually, we don't even need to do this. If we call BS count, it can handle the ref count thing. So we just need offset and size. And honestly, we can just do like... Yeah, you know what? Fuck it. Okay, BS get will handle the ref count. We'll also do something like, I don't know, void star, start is equal to that, and that will just give us, BS will handle it. As in terms of size, yeah, this one's kind of iffy. Let me just jot it down at least. We get start, but it's kind of up to the parser of the snapshots to ensure we don't read past the end. Yeah. And then we can do, from the client, we can do start 0 is equal to start 0. Yeah. I don't know. That's a basic smoke test, I guess, and then we just free it. We free the whole thing. Okay, so this is like how we would use it. Let's actually make it. Let's make it happen. So vi, we're gonna go into. I'm gonna do some copy just to keep it simple. Source, take FL and make that source bs.c. We'll do copy of include FL and we'll make that into source include bs.h. Cool. And now we can actually start doing cool shit. So we're gonna go into, I'm gonna start with the, oh, ew, what the, Jesus. We're gonna start with the source file, and then we'll derive the header from there. But we'll do bs.h, bs, and this is variable size handled blob store. Okay, so let's get started. We're gonna have bs. Oh, we need bs. Okay, we can make it here. Why not? Vi include bs.h. Yeah, we need something like this. Type def will be defined here. Yeah, you know what? We'll build them both at the same time. I don't know what's going to go in here yet, so we'll see. Okay, so bs star bs init, and this is not going to take. What do we decide? Well, this is going to take nothing at all. Are we sure? Yeah, BS can handle everything. We don't actually need anything here. BS star BS init. We'll come back to it, but we definitely need to make at least 2 mallocs. And then we're gonna have BS star BS free. And I think I already know what I need to do here. Since we only have 2 structures, all we need to do is something like, we also need to BS, oh no, this is not gonna return anything. It's gonna return a void, or maybe a integer indicating success, maybe. I have no idea. All right, BS. We're probably gonna do something like free B. Oh yeah, we do need a. Okay, well this is definitely gonna be last, but we also need something probably like BS metadata and BS store. That's probably it. I'm just gonna put this at the bottom. And I think we're good for free at least. And let me update this one. So void BS free BS. Okay, so that's that guy figured out. In terms of actually what we need to do, let's see what we need. We need a reserve. We need a reserve. BS is not actually going to be worrying. UN32. Yeah, UN32 is fine for now. Or is it? Whatever. UN32 BS reserve. We're gonna have a BS or BS star BS size. I mean, if you had a really full order book, this could be pretty big. If you had like 100 prices and on each side you had like 5, well this is, let's just go with UN32 for now and see if we can narrow it down. We have that. We need number of refs, which, I mean, there's no, okay, so this is basically how many possible clients could we have subscribed to this thing. I think 4 billion is fine as a max, because we might have a low resolution snapshot that everyone subscribes to. That's possible. So we'll do refs, and we'll have BS address. This is an address of an address. Yeah, and it's also going to be a void star. Okay, this is where you actually start to think. If it's a void, we need to take the address of an address to a void star, which might just be there's an add here somewhere, I know, but um, address holder, I'll call it that, because basically the server gets it, it writes directly to that address, it doesn't need to worry about anything else, I think. Actually, wait a minute. The server should hang on to this address, actually. Yeah, it should. Okay, well, we'll figure that out. Okay, so what do we need to do when we actually reserve? Here's what we're gonna do. We have two data structures going at the same time. First one is gonna be it's actually kind of tricky to think about this, huh? Okay, there's a bunch of error conditions that could happen. This is actually the much more difficult one. Actually, that's a good point. Let me do this instead. Start with the easier one. We're gonna do void star bs get. We're gonna do bs star and just uint 32 type bs number. This is pretty easy. So all we need to do is go bs metadata bs number, and this is going to be what is this? Okay, it's going to be internal. BSM metadata is going to be that, and then we do BSM refs minus as equal to BSM. I'm just going to make this explicit. Okay, and most importantly, if BSM refs equal to 0 now, if this resets to 0, we basically need to step forward through the BSM list and we need to this one's not easy either. Okay. Size doesn't matter, but we do need offset into memory. Well, let me just, I'll do the easy one. Return void star BS store, but at the offset of BSM offset. That's it. And oh wait. That's gonna return what's there. We need the address of that. So maybe boy, it's like we need the address of this, which might just be that. I'm gonna add a note. Okay. Okay, if the refs are 0, then we basically do BSM, wait. Okay, so the metadata is a, it's a, what is it? Metadata is a circular buffer. So we also, that means that somewhere in BS we have a metadata start, so the start of that buffer, and that's going to be BS This one's correct. We need to get the original. Wait. We get it. We get it, and we still return it, but in between there, we actually dereference it, or we ignore it. We pretend it's not. We stop managing it in the metadata, as if it didn't exist, which means that it could be overwritten by the time it gets there. Wait, shit. Okay, this needs to happen when the client sees it. So this happens, nothing else happens until the client reads the data and is happy with it. Let me jot that down. Because we stop managing this block in the metadata, nothing can happen until client is set with the returned data. Okay. Now what do? We basically need to go through the, we only increment this one ref, but we then need to go increment MD start until, okay, we need this BS metadata BS MD start. Refs not equal to 0. This is what we need. We need to keep going until we get that, and we can actually just start immediately. So while this guy is not equal to 0, if it is equal to 0, then if it's not equal to 0, then we just skip this whole thing. But if it is equal to 0, then we need to go ahead and, oh wait, no, while it is equal to 0, here we go. Well, if what we're on right now is equal to 0, okay, oh, this is actually better than what I had in mind. Okay, so if we're not at the start, so we have like 1, 0, 2, and we just decrement that 2, or we just decrement, if we have 1, 0, 1, 1, and we decrement the second 1 to 0, we don't want to go through the entire list yet. We only want to go through when the start one is good. So then we just go through all those. So yeah, this is the correct okay, we can make this a bit more efficient, slightly more efficient. If BS number is equal to BS MD start, then we do this. Otherwise, we didn't decrement the start, we can't trigger this condition. And then we do this. We do MD start is equal to MD start plus 1, except it's not that simple. It's actually going to be more like, what is this actually going to look like? I don't want to assign new variables here, but we need to throw in BS MD capacity, and we also need BS MD end. Or if we're getting, we can only free. This is a end only comes in if we reserve. If we hit end, actually no, if we hit end, we need to stop because we freed all the blocks, and we can actually reset to 0. Okay, this is interesting. So if the BS number is equal to BS.MD start, now we're going to define it in such a way that if we're freeing and we hit the end, that means that we freed the last one, which means that we can just reset both to 0 and not worry about it. So if we hit capacity, though, we need to loop back around because it's circular buffer. Okay, so here's the actual thing. It's going to be +1, but this can go over, so we need to do this BS MD capacity. Okay, this is metadata capacity, and this will change actually. This one could change. Not sure how, but it'll double if we run out, but this will be handled in the reserve, not here. MD start is equal to that. However, we have a special case. If BS MD start is now BS MD end, this might be a bit messy because if we reset the pointers, they will have some data. All snapshots wiped. We don't necessarily need to do anything. It might just be, if all the clients are out and they read everything and they don't send anything, we can still use that same structure. Yeah, we don't need to wipe out, we don't need to free the whole data, but we do need to, without any new ones, which is not going to be likely to happen based on how I envision this, but we're going to do this. MD start is equal to 0, and MD end is equal, MD end is equal to 0. We could also do -1 here, but do we want to do that? MD end is always going to indicate where the next block is going to go. MD start is kind of like the beginning. If they are equal, that means if they are equal, that can't happen. If they are equal, it means we hit this case and they should have been reset to 0. So this just means that it's empty. So what can we do here? We have a little check. If MD start could be 0 and then MD end could be any other number. So if MD start is equal to 0 and BS MD end, bless you, equal to 0, return 0. That should be a null pointer. So all snapshots freed. Nothing managed. Yeah, so this is specifically reset to this empty state. Do not leave something like both some non-zero value. All right, so this is the empty state, which also tells us that we'll need to do this. BS MD start is equal to 0 and also MD end is equal to 0. Okay, cool. So this is the initial and final condition if it's empty. Cool. So that's get. Still iffy about this one, but otherwise looks pretty good. Anything else that could happen? Probably. Honestly, there probably is some bullshit that could happen, but let's move on to reserve, which is going to be, I think, much more interesting. So if we want to reserve, what can we do? First off, we need a check against MD start and MD end. I guess the problem, MD end is going to indicate the next place to, like the next block to go. Ooh. Okay, actually, if MD start equal to MD end, oh, okay, hold on. We need to, okay, I'm really leaning towards -1 for the MD start initialization. How can we do -1 in, okay, we need fuck. Yeah, -1 actually makes a lot more sense for the start condition. Because we could have the case where we start at 0 and then we fill in everything and then we loop back to the front. Or should we just double at that point? Should we not allow that? Or can we squeeze out a little bit more capacity before doubling? I think we should squeeze out capacity. Okay, so we're gonna need something like this. So, okay, it's gonna be -1, which maybe this just works. I don't know. Let's just see what happens. If it breaks, we'll handle it. But okay, initial state for metadata. Start at -1, end at 0. So actually, let me make this more clear too. -1. Okay. Possible. Start at 0, end at 0 means that the first the circular buffer is full. %. And then the next one will require a doubling of the capacity, but we'll get to that in a second. Which also means we need BS MD capacity is equal to, let's say 1024 for now. This might actually not be that big. This is going to be limited to how many. Oh, actually, if you have 20 million clients on a socket, that could be a lot. Okay, whatever. So we specifically need to check for this condition now. If if MD star is equal BS MD start is equal to BS MD end, then we have a problem, and we're just gonna say return 0. Need to double metadata. The data array capacity. Okay, now let's actually have some fun. Let's say we have plenty of space. We can do whatever we want. All we need to do is, wait a minute. Can we make a method here without putting in the header? Because that's what I want to do for the double thing, because this might get a little messy. Oh god, it's gonna get messy for both of them actually. If we, okay, doubling the capacity of the metadata or the store is easy, because we have the metadata. We can just mess with the starts and ends and whatever, or we can mess with the offsets. Doubling the circular buffer, that one might be tricky because someone outside of this class might rely on those values. But it might actually be cleanest to think that, okay, if BS MD star is equal to BS MDN, that means that we have a full buffer full of data. And we can actually keep that thing, and we can just double it. Or we can just take that and put into a doubly sized allocation. Then we get to keep all those indices, but we'll just say, okay, start is, no matter where start and end are, they're together clearly if it's full, but we can just say, okay, start is now here, end is now here. That should actually not be too bad, but we do need to do some funny copying of arrays, so we'll get to that later. Second of all, if we do need to reserve, okay, this is where the special cases come in. Okay, first off, oh no, I spilled something. Okay, This is actually exactly what we need. We're gonna call it like this. We're gonna do BSM first is equal to BS metadata BSMD start. Okay, and we're gonna do last is gonna be MD end -1. Or should we then modify it so that end sits on the last one? Then we need to do additional mods in a few places. If it's MD, if start becomes fuck it, this is fine. There's going to be some weirdness no matter what. I think this might be the simplest way to do it, because we only need to do one reserve, and this is going to happen a lot. We need to be very careful with what we write here, but this is going to be less often. This is going to be, like, for every one of these calls, there's going to be, like, many of these calls. So we actually should really worry about this one. Okay, let's keep going. So first and last, this just gets us the metadata that we need. And what we're going to do is, so now we're actually going to work with the store. So here's what we're going to do. If first dot offset is greater than end, or last offset, okay, I'm copying this verbatim from my notes. If first dot offset is greater than last dot offset, that means that we've allocated, freed, allocated such that the circular buffer kind of wraps around itself. So the first is higher than last. And in this case, all we need to do is make sure that there's enough room between the last one and the first one to fit the requested data. So I'm just gonna derive it from scratch. So we have first offset has to be greater than last offset plus last size. So this is the end of the end of the last one, and this exact address is exactly what we want for to go into here, but plus size. How do I do this? Okay. I guess it's more like this. If this, then return, can't even do -1. No, just say -1. Like this is, let me describe this real quick. Let me say something like end, last. Yeah, I like that. Return -1. This, it's not just return -1. It basically means we need to double if we want to fit in this guy, and we do need to. We do want to do that. If we don't have enough, this metadata array is going to be fixed size. So this is, if we might need to double if we have, if we can't handle the number of the snapshots, and this we need to double if we can't handle the size of the snapshots, if that makes sense. Store, we need to double store, and the store, this one, again, this one's going to be a bit more complicated, but because we have this bullshit blob store metadata, we can actually just modify the whole array and go from there. And this will probably be another function I write. So first, last offset, -1. Okay, the other condition is this. Okay, else if first offset is less than end last offset, then what do we do? So this is kind of like the case you might have in the beginning. So it's going to look like this basically, except the last, we're going to swap these first. Or I guess it means we haven't wrapped around yet. That might be one way of thinking about it. So we have first dot size, a bunch of other ones. Bunch of other ones, and we have last, and then we have last dot size, and we have empty space here. Now the question, and we actually also have empty space before the first. Now the question is, can the size fit here, or can it fit here? Either one is fine, but it has to fit in one of those. So we'll have to split this check again. So if we actually need to do different things in each case. So let's do it like this. So if last offset plus last size, we need BS, I guess this is going to be store capacity minus this thing. So how much room do we have at the end? If this is less than size, we might not need to double just yet, but we do need to go ahead and check the next possibility, which is going to be if, this one's easier, if it's just first offset is, if it's equal, can it be equal? Well, it definitely can't be less. So basically, is there enough room before first? If what if it's equal? We can just kind of, if the offset of first is at 4 and we need a 4-bit thing, we can do 0, 1, 2, 3. So that's fine. It's just gonna be very tight. If first offset less than size, so this is the error condition. So this means cannot fit after last or before first. We need to double. Okay, otherwise, actually this is going to be really interesting. We're not going to return at all, not yet. Let me just make this more clear. In this case, we just put it after last. So this is the case where it is too big to fit past the end, but we can still put it before the first, so put it at 0. And then we, yeah, okay. Now, what if we do have room before the end? Put it after last. Okay, and I think that's all the scenarios you really have. There's really 3 of them. You can do oh yeah, this is gonna be weird because we're gonna leave some. I was worried about leaving a gap between, like especially in this case, we're gonna leave a gap between last and capacity, but I think that's fine because we're just going to be managing the blocks with a metadata store and doesn't even need to know about them. So here's what we can do. I'm also going to say else. What does this mean? This means that the first dot offset and the last dot offset are equal, which this is verbatim what I put down. If the first and last, we should have caught this. We should not have inserted it. Already fucked. Should have guarded against this. Let me just do like a printf. This should not happen. New line. Cool. I'll just get the old stdio. I love that thing. Okay, cool. This should not happen. Okay, next up. I mean, we got a good shape of this, but whatever. What about the start condition? What can we do? If it is the start condition. Okay, so this is assuming that. Oh, wait a minute. No. Huh. This is actually going to happen very quickly as soon as we try to enter the second one, because these are going to be the same. So, this is specifically in the case that these two are not equal. So, and we also have a start case, which we need to handle maybe separately, maybe not. So let's just say this. If first not equal to, wait, this is, oh, now specifically if BSMD start, but then we still need to loop around it, don't we? Wait a minute, even this is wrong because it could be, metadata. Yeah, the metadata is circular buffer, so we need to, oh my god, okay. This is fine. This is fine, but if we're gonna shift back, how could this happen? If, oh yeah, okay. So if start is at like 3 and then end is at 0, so the next place we're going to put it is at 0, this will break it. So we need to do something more like this. It's a hair ugly, but okay, you went 32 type last metadata index is equal to BS MD end. We're actually going to do plus BS MD capacity, metadata capacity, then -1, and then we normalize it to be we mod it MD capacity. So this will move us backwards correctly no matter what. We can just do last MD index. Now we have the case where if BS MD start is equal to last MD index, does this mean that we have 1 or do we have 0? Oh my god, this is even weirder, because if we have, in the start case, we're going to have if we have only 1, then we're basically in this case. We're in this case, which is first dot offset is going to be last dot offset because it's only 1. So if there's only 1, we don't even need to do anything special. We don't, because in the case that we only have 1, then, okay, so that means, Hey, wait. If we, in the case that we only have one, then one snapshot in, then first offset is equal to last offset, which is ugly, but you can just do this. So yeah, because if we index one, it's not going to wrap around. Okay, in the case that we only have one, and we handle it equivalently to first less than last case. So we don't worry about that, but we do have another explicitly almost zero scenario. If we have zero, then if there's nothing in, then this is going to be garbage and this is going to be garbage as well. So we need to like explicitly handle that, and we just put at 0. So will it catch this? First offset, last offset 0. Okay, whatever. We'll explicitly. If you have 0, we need to explicitly handle it as -1 is not an index. Cool. If BS MD start is equal to -1 and BS MD end is equal to 0, then what do? We have one check to make, and that is this is actually slightly easier, because if we don't have any metadata, then we don't need to copy anything. Easier case because, but it's going to be rare. Like, there's always going to be some snapshot pending, and some people haven't read it yet, so I don't think it's ever going to happen. Easier but rare case because we don't need to copy, we just free and malloc. Okay. Cool. So that's store capacity. But otherwise, well, no, we'll double it until it fits, and then we'll just put at 0. Okay, now let's actually start indexing these things. What does it mean? What does it mean to do I have time for this? I have a few minutes. Okay. Put at 0. What does that actually mean? It means. So this is a specific case where we don't have anything. I think this might be the only time where we do BS MD start is equal to BS MD start plus 1, as well as for end. Wait, yeah, we kind of initialize it, don't we? Oh, could we have, well, we want MD end to be 1, we want MD start to be 0, so couldn't MD start and MD end both being 0 do what I needed to do? Nah, fuck it, this is good enough. Okay, so put at this 0, this updates the BS, and then what we do is we do BS MD metadata, MD, oh wait, we need to move these. This is not going to work actually. These 4 too. I'll probably have a return here, honestly. This is its own special case. BS metadata, this is going to be BS MD start. What do we do with this guy? We don't need to do anything with MDN. That's just going to be normal, but this is going to have a few things. We're going to have ref count. Refs is equal to refs. We're going to have offset into memory. This is specifically going to be 0. And then we're going to do size of block is going to be, which I don't even know if we need. If we can scrap this one, that'll save a bit more memory. We needed it earlier because, oh god, I have no idea. We'll keep it for now. Okay, this will be size. Cool. So now we have that. Oh no, we do need this. We do need this because next one we create, we'll use size to calculate where to put it. Okay, cool. So that's first dot offset last. Okay, let's actually do some of the other one of these. Put it after last. What does that mean? That means that MD end or MD end increments, but before that we also need to do a few things on the end. So this is actually going to be the last thing we do. But we're going to do we're actually going to do something very similar to this. Actually, we can keep this this write the end and then update it pattern pretty much everywhere. See? So in this special case, MD end is at 0, which is exactly how we want to use this. So we can do that, and then we can copy this whole pattern everywhere we need to place things. So MD end refs is equal to refs. Yes. Offset is not going to be equal to 0. Offset is going to be last plus size. Yeah. Yeah. Last offset plus last size. And size is going to be size, of course. Next one, put it at 0 is actually going to be exactly the same as this. Put it at 0. And we're going to do, as always, increment MD. Oh, fuck, it's not going to be that. It's actually going to be this. We need to mod it, loop it around. I mean, just to be oops. Okay. The other one is put it after last. Wait. Oh, we always put it after last, actually. It's just slightly different conditions. And same thing here. And refs is going to be refs. Offset is not going to be 0. Absolutely not. It's going to be last offset plus last size. Cool. And then yeah, so that's handled. Put it after last. So there's only 2 scenarios where we need to double, where there's not enough room between last and first, and there's not enough room in the little pockets between here and here. Now, how do we double this? And that's going to be more interesting, and I'll probably save it for later. Let me just make a note of everything I have real quick. We need doubling code. Basically take each snapshot, I'm not gonna say snapshot, take each blob from start to last. Okay. Make an array, double the current size. or double capacity, double the current at the new capacity. Take each blob from start to last, copy it to new. Copy it to new. New array and update. We're not going to need to update size. We just need to update offset in the metadata. Okay. Copy to each new array and updates offset metadata. Free old array. And now that I think about it, this will, because the way we were doing this, the way we're doing reserve is that this address holder is going to get messed up. But as long as clients get this, they write it, and then no one tries to reserve it again, then we should be fine. So let me just make that clear. Address holder will be messed up when we, if we need to double the array size, the store size. Clients must write, or I guess the server, users must write to the address before calling BS reserve again. Yeah, okay, that's a little invariant there. Free old array, I think this is really all we need. Doubling the other guy is a bit more interesting, but it's whatever. Now let's say we do this, right? So we have, oh God, and then at that point we need to do some kind of like try again. But in this scenario, it's specifically gonna be between last and capacity, because we rearranged it such that first is first and last is last. Try again, check between end and capacity. Yeah, and the same thing for here. Let me D8D, D9D, okay. There we go. Because there's not going to be any room between the first one and 0. We're not going to return 1. We'll handle it. Okay, I think that's a good place to stop. Maybe. Well, will not compile. Added files for blob store. Cool. Let's take a break.